Hey y'all, it's your math teacher, Mr. Boyden, back at it again, and today we're going to be looking at functions and their domains. So first, let's talk about what is a function. Simply, a function is a rule that maps, or you could say assigns, values from one set into another. And I say here it's set A and set B. Those are just arbitrary letters as placeholders there, but from one set into another. Now, what we mean is maybe a function does something like this. Like maybe it takes the numbers 1, 2, 3, 4, 5, and so on, and it turns them into the numbers 2, 4, 6, 8, 10. So this is exactly what we saw with sequences, where we have one number we call that a mapping, or it's assigned, and the second one is 4, and the third one is a 6, and the 4 turns into an 8, and the 5 turns into a 10. So here's what we mean by sets. Set A, if that was set A, that is the counting numbers, or the natural numbers. Set B, in this case, so we're going to call these numbers set B, are the even numbers. So that's what they say from one set to another. They're not necessarily the same numbers, but they might be. Okay, so there's a lot of options there. The inputs are called the domain, and the set of outputs are called the range. Those are in bold because they're vocab that we need to know. And down here we have an example. It takes inputs right here, and then outputs come out as y. Another thing I want to point out here, and probably the most critical thing that people miss, is that it assigns a value from set A to a single value in set B, not to two values. So to understand that, let's look at some visuals. Okay, and we're going to look at the same three graphs that we had in the previous video. And so what we're going to look at is our input values, and think of input values in this case as x values, and the outputs are the y values. So here we see an example where each input, well, not each of them, but many of the inputs have actually two outputs. So for example, let's go to an input of 1. So input is x equals 1. What are the output, or what is the output or outputs for that? So we have y equals, looks like y equals 3, and y equals negative 3. So plus or minus 3. So here we have a case where a single input produces two outputs. So is it a function? No, it's not. It has to have a single output. Now, what we usually can do to identify quickly on a graph, if we're looking at a function, is something called the vertical line test. And the vertical line test is super simple. All it is there a way for me to draw a vertical line that hits the graph twice? Vertical line, well, I missed a little bit, but a vertical line would hit the graph at two different points. For example, a vertical line could hit both of these. That means it fails the vertical line test, so it's not a function. So with the vertical line test in mind, let's look at another one. Is there a way on this graph for us to draw a vertical line that touches the blue function twice? Now I draw vertical there, only hits once, vertical there only hits once, vertical there only hits once. So what that tells us is that this is a function. So we say yes. Each input has exactly one output. If my input is 2, I only have one place where I hit the function there. So yes, this is. What about the third one? Does this pass or fail the vertical line test? Yeah, I don't see any place where I can draw a vertical line that hits it twice, which means it passes. So yes, this is a function. Let's look at the notation of functions. Okay, so typically what we do is we use this right here. We say f of x, f of x, or it's short for f as a function of x. Okay, and that's also known as a function value. We've seen y equals a lot, so let's consider then what does f of 3 mean? F of 3 says, notice 3 and x are in the same spot, it's saying please plug a 3 into the function defined as f. Okay, and then the one other thing we got to talk about is, why do we need function notation? Couldn't we just forever get away with y equals? Not necessarily. So the issue is, if you're dealing with a complex context where you have more than one function going on at once, you need to give them different names. So maybe one of them is you have your income as a function of units sold. So income is a function of units sold, and maybe you have also your costs as a function of units sold for some company. So you have multiple functions going on. That's much more descriptive than saying y equals and y equals. So that's why we use the function notation. Let's practice evaluating. Okay, we're going to evaluate the equation given, there it is, for the given inputs, also known as finding the function values. Here we go. I think you're going to find the first couple pretty easy. Okay, so all this says, notice that's an x in the same spot as -2. So all that's telling us to do is we're going to write this same function, the f function, but instead of writing x, we're just going to write -2. So -2 times -2 squared plus 3 times -2. They asked us to evaluate, so we're going to turn that into a single value. So I'll start simplifying. -2 squared is 4, so -2 times 4, plus, we get a -6 here. So that turns into -8 minus 6, which gives me -14. What about the next one? In fact, notice the next two, they're not single values we're plugging in, we're plugging in expressions. That's totally fine. It feels funny for a lot of people at first, but it works just fine. Works like this, in fact. -2, and then instead of x, we'll write -x squared. You must use parentheses. Plus 3 times -x, and then we'll simplify. Okay, so when you square the negative, it goes positive. So we get -2x squared. And then we have 3 times -x, so minus 3x. Now, for some people, that's a little bit dissatisfying because they want it to be something a little bit more neat and clean. But that's a simplified expression. That's as much as we can do, so we're going to leave it alone. Okay. What about when you plug in a little bit more interesting expression? We're going to plug in a binomial here. So we get -2 times x plus 2 quantity squared plus 3 times x plus 2. So we'll have to do a little bit of simplification here. I'm going to do x plus 2 times itself. So what we get when we do that, we get x squared plus 4x plus 4. And then I'm going to distribute the 3 right here. So I get 3x plus 6. And we'll have to continue simplifying. So -2x squared, because I'm distributing here. Boom, boom, boom. So that would be then minus 8x minus 8 plus 3x plus 6, and now we'll combine our like terms. So it looks like -2x squared. All right, we've got minus 8x's there and plus 3x there. So that looks like that's minus 5x. And then we have a -8 and a 6, so we have a little -2 at the end. All right, now we get to talk about something really exciting called piecewise functions. Okay, as you can see, this function doesn't have just one line like the previous examples. This one has 3 lines, or as we're going to call them, they are 3 pieces. Okay, piecewise functions. Over here, this stuff is talking about the domain. Okay, we call these domain restrictions. That's telling us what types of numbers get plugged into each line. The common mistake people make is, for example, when we're doing f of 0, they'll plug a 0 into the whole thing everywhere. That's not what you do. You first look at the domain and you say, which of these 3 lines over here can take in a 0? Okay, well this one says x needs to be bigger than 12, so it's not that one. This one says x has to be larger than 0. It's not that one. This one here says x could be less than or equal to 0. So that first line is the one we're going to use. So while this looks like a really challenging question, all we do is identify the line and then plug it into that line only. So here's what it looks like. We've identified that it's the first line, so I get -0, which looks kind of funny, plus 2. I'm guessing you can probably add those together in your head since it's 0, and you get √2. That's all it is. So what about the next one? f of 12. We have to decide which line it goes in. Okay, this says less than 0. No, 12 is not less than 0. This says more than 0 or less than or equal to 12. I think that's it. Let's check this one. This says if x is bigger than 12, it's not bigger than 12. It is 12. So we use that middle line. So -9 times 12 squared plus 2. Okay, we know that 12 squared is 144. So we get 9 times 144. Oops, looks like I forgot the negative. Plus 2. So 9 times 144 gives us 1,296. So -1,296 plus 2 gives us -1,294. All right, what about the next one? 25. So now you may want to pause the video and try these on your own. Determine which line they go in. If you're ready, here I go. Okay, we plug into 25. 25 fits best in this last one, okay, where we have 25 is greater than 12, and it says that when that's the case, our y value is 3. That's it. So don't be intimidated by these, and notice we're doing just one line at a time. The other thing that's weird, we read most math and most writing left to right. We actually interpret this right to left, because this is our domain, and then these are our functions that go with our domain. But we have to determine which domain we're applying before we look at the function. So you actually read right to left on these. It's kind of strange. Okay, what about f of negative 2? That applies here. So I get the square root of the opposite of negative 2 plus 2, which would be the square root of 4, which is 2. Maybe we should try another example. This would be a great one for you to pause the video and try on your own. Okay, for the first one, when I want to plug in a negative 100, that only fits in this first line. So I have negative 3 times negative 100, and I get 300. Second one, negative 5 cannot go in the first one. It has to be strictly less than. And wait a minute, it can't go in this one either, because look, this is strictly greater than. And negative 5 doesn't satisfy this condition. So this is a case where we have an input that's not defined in the domain. So all we're going to say is it's not defined. Because there's no place that we're actually able to put a negative 5 in here and have it be a true expression. So this is a weird case where the input is not defined. Maybe if it'd be like it's synonymous with your calculator saying you had a syntax error or something like that. Okay, what about the next one? We're going to plug in a 0. They're trying to trick you here. It actually goes in this one. So we get 0 over 2 with a square root, which would be kind of like the square root of 0, which is 0. And then the last one, oh no, a fraction. Well, actually, it's not that big a deal. This right here says any positive number as an input will turn into pi. This is a positive input, so it turns into pi. And that's all that is. Okay, before we talk more about domain, let's make a quick note on what set notation is and what it looks like. This is a way of describing what numbers we're including in our group of numbers. That group is called a set. Okay, so this is the notation. It looks like a lot. It's the kind of thing that if you pull it out at the dinner table at home, your family's going to think you're a genius, which is very, very fun. I encourage you to try it. Okay, but all this says, the domain is going to be real numbers, meaning not imaginary, just means numbers, okay, such that it isn't 3 and it isn't 5, and it could be anything else. What about this one? This says the domain is the real numbers such that you're only talking about numbers that are bigger than 2. Okay, so with that in mind, let's talk a little bit about domains. Okay, the domain is the set of numbers that are viable inputs for a function. Now, when I say they're viable, that means like literally any number that you could put in and it would work. Also known, as this second line says, they're the numbers that don't get rejected. So before we go looking at domains, we need to think about why would a function reject an input? And one way to think about this is like if you're typing numbers in your calculator or you're doing functions in your calculator, what types of things return back a message that says there's an error in syntax or a math error or something like that? There's only two that I can think of. One is anytime you're dividing by 0, it's going to reject that. You can't divide by 0. The other one is going to be anytime you take the square root of a negative number. Now, I bring that up now because when you get domain questions, sometimes students get really flustered. They don't know what they're looking for and they don't know what to do. You're really just looking for these two things right now. You're looking, am I at risk of dividing by 0? Am I at risk of taking the square root of a negative number? Because we're not going to deal with imaginary numbers for right now. So knowing that we're looking for those two things, let's look at a few examples. So the prompt is find the domain of the following. Here we have a function, and it jumps out at me right away that we have a potential to be taking the square root of a negative. Now don't just look at this and guess what numbers would cause a problem. Okay, we actually have to do the math. So here's what I know. I know that that thing under there, negative 6x plus 2, that needs to be 0 or positive. So I'm going to write that. Negative 6x plus 2 needs to be greater than or equal to 0. That's the only requirement. If I make sure that this function under here simplifies out to be positive or 0, we're all good. So now I get to solve this. I'm going to add 2 on both sides, so negative 6x greater than or equal to negative 2. We'll divide by negative 6. And then you need to remember that anytime you multiply or divide by a negative, it flips the inequality. So what we get is that x is less than or equal to 1/3. Now, don't get frightened by all this notation up here, okay? Because notice, it's always the same. You have a brace, that symbol's called a brace. X is an element of the real numbers such that. X is an element of the real numbers such that. All we're filling in is this second part. So that means it's not going to be very hard. Okay, all we're going to do is I'm going to take what I already have as my work. I'm going to put a brace over here. And then I'm going to say x is an element of the real numbers. And I'm going to put d equals. The domain is the real numbers such that x is less than or equal to 1/3. Okay. Now, people sometimes get confused. They say, wait a minute, Mr. Boyd, and I thought you said that we had to make sure it wasn't negative. I mean, 1/3 isn't negative. Why couldn't it be 1/6? Because it's not about whether or not the input is negative. It's about whether or not this whole thing is negative once you've multiplied by negative 6 and added 2. Okay, let's look at another example. Okay, so down here at the bottom of the page, we look again. Remember, the two things that could go wrong are the square root of a negative number or dividing by 0. So there's no square roots here, so that doesn't come into play. And notice, like, you can cube any number you want, or subtract 3 from any number you want, or multiply by 3 with any number that you want. However, we do have division. So what we have to make sure of is that x squared minus 4 could not be 0. And so the logic of this is different than what we're used to. It's sort of a complementary logic is what we call it, because normally we're looking for things that are good. When they say find the domain, they're asking for the numbers that work. But the way we figure that out is we start out thinking, okay, pretty much all numbers work. We're going to go search for the ones that don't. Okay, so right here, I'm going to search for the numbers that cause a problem. We're going to get rid of them, and we're going to keep everything else. So what would make this equation true? Well, I could rephrase this as x squared equals 4, and then we'd say, okay, well, if we took a square root, we would get x equals plus or minus 2. Before we write our answer out, we have to decide, are those the numbers that are good, or are those the numbers that are bad? Well, those are the numbers that would make the denominator equal 0. So those are the numbers that are bad. So the only little tweak I'm going to make is I'm going to say x cannot be equal to plus or minus 2. So x as an element of the real numbers, and that's my domain. Okay, let's try another one. Okay. In this question, the first thing we have to notice is that there's a 1/3 power right here, and we have to decide if that's dangerous or not. So in order to understand that, I'm actually going to rewrite out the question as 3x minus 7 with a cube root and a square root of negative x minus 2. Now, we're going to look and see what could possibly cause a problem. We have division, so there's the potential for division by 0. We have a square root, so there's the chance of a square root of a negative number. And then we have a cube root. Do cube roots cause problems or not? So when you take a cube root, what types of numbers are you able to have under there so that they don't get rejected? Can you take a cube root of a negative number like negative 8? Well, it turns out that you absolutely can. It's negative 2, because negative 2 cubed would be negative 8. So maybe I need to add something to the notes up here. So what we're going to actually be looking for is even numbered roots to cause a problem, because odd numbered roots don't cause a problem at all. So with all that said, this cube root in the numerator is actually a red herring. It's not going to cause any problems at all. All of our issues are going to come from the denominator. So what we're going to focus on is this little function inside the root, negative x minus 2. And the question that we have to answer is, what type of number can that come out to be? Is it okay if it's positive? Okay, let's see. That would mean we'd take a square root of a positive number, and then we'd be dividing by that positive number. Okay, that would be fine. So if it's greater than 0, that's totally fine. Is it okay if it is 0? Let's see. Do we know how to take the square root of 0? Yes, we do. That's 0. So that's fine. However, that would then mean we're dividing by 0. So we need a strict inequality, because if this thing turns out to be 0, we'd be dividing by 0. So now we just need to solve this. So negative x is greater than 2, and then I'm going to multiply by negative 1, and that's going to flip the inequality, so x is less than negative 2. Let's finish up our notation. And now we are done. So y'all, that's how you find the domains, the set of viable inputs for a function. Hope this video was helpful and made sense to you today. It has a lot of symbols, but do realize they say really simple things, okay? That's all for today. We'll see you next time.